The radical 3, rad 3, is not a common factor of the bottom. You can't really factor it out. Sherry? Can I square the top and bottom? No, because if you think about it, that's a good question. If I have 1.5, if I square the top and bottom, we have 1.5. Does it equal to 1.5?
No.
No, it doesn't. So you can't just square the top numerator and the bottom denominator. It doesn't. They're not equivalent, right? So you can't do that. Okay. So that's a good idea, but no. Yeah. There's actually a think about what Angela. What do you think? Simplify 5 rad. Oh, 5 minus 2 rad 3? How? You can't simplify this any further, can you? Okay. 1, 2, 3 people still. Okay. No one else sees it? Look at example 5 and 4. Look what happened to all the square roots. They're all gone. How do we do that? Anybody see what to do? Okay. Brandon?
Yeah, multiply it by 5 plus 2 rad 3.
5 plus 2 rad 3 to top and bottom. You're right. Where did you get that from? Where did you get 5 plus 2 rad 3 all of a sudden?
From the example 4 and 5.
Yeah, look at example 4 and 5. Look what happens if you multiply by the same binomial, right? Except what? One of them is addition, the other is subtraction. What happens when you do that? When you multiply like that? All the radicals go away because you'll be squaring the first term and the last term. Do you understand? And then all the middle terms cancel out. You see what we're doing? Isn't that a good idea? Because if I now do this, I get rid of all the square roots. Yes? If you don't believe me, go ahead, try it out. Go ahead and multiply it out, see what you get. By the way, what is the same thing over same thing? What is the value of this fraction that we're multiplying top and bottom by? The whole thing is just 1, right? So the fraction, it doesn't change its value, does it? Okay, go ahead, everybody try, see what you get. Hey guys, you see why one of them has to be addition, the other has to be subtraction? Same exact binomial, otherwise the middle terms will not cancel out, right? We just saw that before. Okay, so when I do this, who could tell me what I get on the numerator? Well, I'll do the numerator for you. That's easy. Yeah, you get the same thing because you're just multiplying by 1. What about the denominator? Isn't it going to be something squared minus something else squared? You guys remember this pattern? A plus B minus A plus B times A minus B is A squared minus B squared. So this time your A is what? 5. What's your B? 2 rad 3. So don't you get 5 squared minus 2 rad 3 squared? Isn't that what it's going to be? Always, it's going to be always like that, right? When you're multiplying these, right? Binomials with different operation in the middle, right? So I get numerator stays the same. Who can tell me what I get on the denominator now? Sam. 25 minus 4 times 3, which is 12. Would you not agree? Because what is 2 rad 3 times 2 rad 3? Well, 2 times 2 is 4. Rad 3 times rad 3 is 3. So how many people got 5 plus rad 3 over 13? Raise your hand. Very good. Look at the denominator. What happened to the denominator? All the radicals are gone. You see how we did that? That's the trick. You got to multiply that binomial by the other binomial that looks exactly the same, but one of them has to be addition, the other has to be subtraction in the middle. Yes? Do you get the idea? Do you see the trick? Hello? Yes? So what if I have this then? 6 over 3 minus 2 rad 3. Do you think you could rationalize the denominator? Meaning get rid of all the radicals in the denominator? Make it into a rational number? Right now you have an irrational number in the denominator. How do we do this? Okay, who could tell me what to multiply top and bottom by? If I have this, first of all. Yes, Emily. 3 plus 2 rad 3. By the way, there's a name for these. Look at the denominators. You see this binomial with different signs in the middle? Right? These are called conjugates. Okay. So I don't want to say every time, oh, the same binomial with one of them addition, the other subtraction. That's kind of long to say it, right? So we give it a name. These are called what again? Conjugates. Okay. So please remember. Go ahead, everybody try. So who can tell me what I get on the numerator? If I multiply 6 times 3 plus 2 rad 3, what do I get there? Yeah, one person? 2? Hey, Sherry?
18 plus 12 rad 3.
18 plus 12 rad 3 is correct. Now, what about the bottom part? The denominator then becomes what? You will see that you will not, if you get some radical, that means you did something wrong, okay? You shouldn't get any. Okay, Aaron, what do I get? You got negative. Why do we get negative 3? Because you get 3 times 3, which is 9. So 3 squared minus, what is 2 at 3 squared, Aubrey? What is 2 at 3 squared?
Oh, it becomes
4 times 3, so you get negative 3, right? Because, 9 minus 12, right? Okay, am I done? I'm not quite done. Why not? Why not? You're right. I'm not quite done. Always what? Simplify. Yes. What can I do here?
You can factor the negative 3.
Yeah, I could factor the negative 3 from the numerator, right? Because remember, if you have a common factor, you want to cancel that with the denominator, right? So if I factor out the negative 3 from the top, don't I get negative 3 times in quantity negative 6 minus 4 rad 3? Yes? And then when I cancel out negative 3 and negative 3, what do I get? Negative 6 minus 4 rad 3. Right? By the way, can I write this as negative 10 rad 3? Because isn't negative 6 minus 4, isn't it negative 10? I can't do that? You're right, you cannot do that. Why not? Think of it as this. Negative 6 minus 4x. Can I subtract negative 6 and 4? No, it's multiplication first, right guys? Right? Remember order of operation. Please be careful. Don't you do all this work and at the end you write negative 10 rad 3, then the whole thing's wrong. Please don't do that, okay? Any question? You understand? Yes? Okay. Why don't you then try this? Now you should be able to do this without much problem. Go ahead. Do it this quickly. Justin, what did you do? Yeah, on the top only? Only top and bottom, right? Because what is, after all, we're really multiplying by, what is 3 rad 7 plus 5 over 3 rad 7 plus 5? What's the value of that fraction? Guys, what are we multiplying this fraction by? Yes.
1.
Thank you. Same thing over same thing is 1. So it does not change the value of this fraction at all. Right? We're just now getting rid of the radicals. Okay, on the numerator, who could tell me what I get on the numerator? The numerator becomes, yes.
15 rad 7 plus 25.
That's right. Did you all get 15 rad 7 plus 25? What about the denominator? Okay, Soy? 38. Why did we get 38?
I did 3 rad 7 squared minus 5.
Yeah, 3 rad 7 squared minus 5 squared. Isn't that right? So what is 3 rad 7 squared, class? 9 times 7, right? Minus 25, which is? 63 minus 25. How many people got this? 15 rad 7 plus 25 over 38. Raise your hand. Okay, very good. Okay, you could factor out a 5 from the numerator, but then it doesn't cancel out with the denominator. So if the denominator had a factor of 5, then that would help you to simplify more. But since it doesn't have any factor of 5 on the denominator, you don't need to do that, okay? Yeah. Any other question? Does that make sense? All right, are we good? All right. So now, okay, so every time I do conjugates, and when I give you example 9 like this, people think that, okay, first of all, look at example 9. 5 rad 5 minus 2 rad 13 squared. How many people think that I could get rid of all the square roots? Raise your hand. Would all the square root go away? How many people think? Okay, one brave person. My question is, would this be like kind of like a conjugate? Because some of you asked that question too, right? If I were to multiply 5 rad 5 minus 2 rad 13 times 5 rad 5 times 2 minus 13, would all the square root go away? Yes. No, why not? How come this one it won't?
EST.
Yeah, this is perfect square trinomial. Does it cancel out the middle term?
No.
No, so this is different than the conjugate. You understand? So that's why I gave you this example. Okay, people think that automatically when you square something, everything goes away, all the square roots. That does not happen, does it? Okay, if you don't believe me, go ahead and multiply it out. Tell me what you get. Go ahead, everybody try. So you guys remember how to do this? Okay, Chris, what do I get when I multiply the first term and the first term? 5 rad 5 times 5 rad 5. This one right here.
25 rad
25 rad 25, which is 25 times?
25.
Yeah, what's rad 5 times rad 5? 5, right? What about the second term? When I multiply 5 rad 5 times negative 2 rad 13. What's that? Negative 10 square root of 5 times 13. Isn't that right? Yes? Hello? Isn't that right, guys? And then what do I get if I multiply negative 2 rad 13 times 5 rad 5? I get negative 2 times 5 is negative 10. Square root of 13 times 5 inside. We'll do that later, right? Whatever that is. And then, lastly, why is this addition? Yeah, 2 negatives, right? This is really plus negative if you want to think about it that way. Right, guys? If you want to do it that way, that's fine. And then, okay? You get, how do I get 4 times 13? Where did that come from? Yeah, negative 2 times negative 2 is 4. What is rad 13 times rad 13? 13. So, I get 125 minus 10 rad 65 minus 10 rad 65 plus 52. Am I done? No, now I have a like terms, don't I? I use the distributive property to rewrite this as 125 minus 20 rad 65 plus 52. How many people got this? 177 minus 20 rad 65. If you didn't, ask me now. Any question? Does this make sense? So look it. Did all the square root go away? No, it didn't, right? So only time all the square root goes away when you have a binomial with radical is if there are what? Conjugates. Right? If they're conjugates, then that's how they go away. Right, guys? Any questions? Does this make sense? Yes? Alright. So this is a little bit, this is actually from 10.8. I'm kind of going back to 10.8 now. Okay, so anyway, so they may give you something like this for your homework. Square root of 15 minus rad 3 over 5. Okay, they say simplify. Okay. What's wrong with this, first of all? You should always simplify. Is this simplify each of those square roots? No, what's wrong with the second one, guys?
It has a square root in the denominator.
Yeah, you got a square root in the denominator. So this time it's not a binomial like we had before, right? Whoops. So what should I do on this one now? How do I get rid of the square root of 5? Yes?
You multiply both sides.
Yeah, this time you just multiply top and bottom by square root of 5, right? So multiply top and bottom by square root of 5. So then I get rad 15. By the way, rad 15 is. Can I simplify this any further? No, I can't. Minus. What about this? I get rad 15 over 5. Right, guys? Any question? So I'm done, right? Not quite. Liam, what?
Wait, I have a question.
Yeah.
Why couldn't you just multiply the whole thing by its conjugate?
Oh,
Rad 15 plus rad.
because it's not a fraction. You don't want to. You don't want to just all of a sudden multiply something by a conjugate. Only way we did that was because it was a fraction, something over something, right? Like you don't just multiply something by a conjugate all of a sudden. Then it'll change the whole value. You know what I mean? But if it's a fraction, yes, you could do multiply top and bottom by the conjugate because same thing over same thing is 1. Right, very good. So now what do I do then? Am I done? You should rewrite this as 1 fraction. So how do I do that? This is really over 1. So is there a way to make, write them as multiply top and bottom by 5. Then now it's okay because that's 5 over 5 is 1, right? So then what's that become? You get, what is this? 5 rad 15 over 5 minus rad 15 over 5. So what does the numerator become when they do that? The numerator becomes, yes.
4 rad 15.
Yeah, it's 4 rad because this is 1 on the numerator. Isn't that right, guys? This is 5 rad 15 minus 1 rad 15 all over 5. And using the distributive property, what do I get? It's a nice review of what we just did, right? In terms of 11.8. So you get 5 minus 1. You guys remember the invisible 1? Rad 15 over 5. So the answer is what? 4 rad 15 over 5. Any question? Okay, so if they give it to you these on the homework, right? You know what to do, right, guys? Pretty simple. Always simplify. Write this as a 1 fraction. Okay. All right.